Good morning, everyone, and welcome back to Project CD Chronicles. Today, I couldn't help but start with this iconic screen of the Commodore 128, physically powered on and still in perfect shape after more than 40 years, along with all its equipment, the 1570 and 1541 drives. With this video series, we will thoroughly discuss the Commodore 128's basic programming language, its intricate hardware, and also explore its historical counterpart and the computer it was originally supposed to be. Stay with me until the end because you'll be part of an adventure spanning over 40 years, the Commodore 128. And after that brief introduction to the physical Commodore 128, as promised, in this video series we will cover the basic 7.0 of the Commodore 128. At the end of the video, in addition to a bit of software, we might also talk about some features of the Commodore 128. So we'll spend a few videos discussing software, hardware, and maybe even some historical tidbits. Generally, anyone who gets to this point and is approaching the Commodore 128 for the first time already has some knowledge of the BASIC used on the 64, which is compatible. But what are we going to do in this video? We'll commence with the usual, so to speak, the Hello World program, and we'll intentionally skip over the part where we explain it in extensive detail, focusing instead our attention primarily on this particular section. Obviously, when making a direct comparison to the programming environment available on the venerable Commodore 64, it becomes abundantly clear that BASIC 7.0, a more advanced iteration, distinctly offers a substantial array of additional and enhanced options, particularly concerning the variety and functionality of its integrated commands and programming capabilities. Now let's start with the print command. As you can clearly see, print effectively outputs a string of characters, and in this particular case, we're going to carefully look at the significant evolution in BASIC 7.0, which remarkably allows us to fully utilize the powerful using command, as you can distinctly observe here, for the precise purpose of comprehensively formatting strings, and I'll thoroughly explain why. But first, let's proceed to run it. Let's execute the run command, and of course, at this point, the physical machine commences its startup sequence. And as you can clearly observe, since here we need to briefly go back for a moment, the displayed number is precisely 123.4556. What exactly does it do, or what is its function? It prints the output in a clearly formatted and well-structured way, and at this particular point in time, not only is it meticulously formatted, but it is also perfectly aligned and presented. So if we carefully look here, it meticulously prints the 3 significant decimal digits, and in this particular case, since it is printing only a single digit, it precisely rounds the number accordingly. But we can do even more than that. We can precisely insert a plus or a minus sign before the numerical value, and we can also thoughtfully add a series of distinct hash marks at the very beginning, where, as you can clearly see, it perfectly and aesthetically aligns the entire output. Why is that? Because the Commodore 128 was created, and moreover, it didn't have much time to evolve, in a period when PCs were starting to come onto the scene. Of course, Commodore eventually went bankrupt and we moved on with MS-DOS, but the idea was that this machine would no longer be just for gaming, but would also be designed for small offices. Obviously, for us today, it's clearly just a toy. But at the time, people were already thinking about using these machines for small office programs as well. So just think about how important this instruction was for automatic formatting, for being able to create a report, a case study, or anything else. And in my opinion, this was already an advantage from that perspective. Well, there isn't really anything else of significant importance to add here at this particular moment. As you can clearly and easily see, it's truly and remarkably very simple, a straightforward and illustrative example program demonstrating the effective utilization of the using keyword. I entered 1, 2, 3, 4, 5, 6, and this prints out. All right, consider this as a sort of hello world. Now, still within this particular context, the print command was also significantly enhanced with various other programming constructs. Indeed, one of the very few instructions that was considered in the absolute smallest number of specific cases and thus rarely utilized was the putf command. Well, what is this strange instruction? Actually, the syntax clearly doesn't help with this, but let's take a look at this output. Well, this doesn't tell me anything. Let's go back to the basic program. But in fact, nothing has changed. Where are the two screens? It's still 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. The formatting with using hasn't changed at all, but what has changed is the putf. Yet when we look at the change in the display itself, we notice that instead of the dollar sign, we have the lira, and instead of spaces, we have periods, and instead of the comma or the period, which let's say is American, so the American dollar, we have the lira, which is Italian. So what does this mean? What happens? What happens is that putef is an instruction that allows us, already designed with the spirit of small office commerce in mind, to reuse the same code but change the way the characters are displayed. It's a bit like what we would now call the locale, right? So I remember that in America they use the period, while for the lira we use the comma, they use the dollar, and we don't use the lira. And in fact, it tells me replace the space with a period, replace the comma with the period itself, and replace the dollar sign, which we'll look at more closely in the syntax, with the L, and this is basically how it works. So what can I say? This is definitely an introductory part. Now let's take a quick look at a brief historical overview very quickly, and then we'll meet here again with this topic, a bit about the Commodore, a bit about the software, a bit about the peripherals, and we'll try to give a quick overview of everything. A very basic summary course about a machine that was, that is, and that never saw the light in all its potential. Clearly, Wikipedia isn't the official source for everything, but often it does provide information that, even if it needs to be verified, let's say, is very useful to us. And here, very succinctly, it talks about the Commodore 128, its introduction around the years 85, 89. And I remember that Commodore was already starting to decline. And also during these years, Jack Tramiel left Commodore. So the group basically found itself having to, so to speak, try to release a product that to somewhat turn things around. But in reality, as we've seen, history has taught us that failures followed, even probably also due to lack of funds. Products like the 16, the Plus 4 did not succeed. The Amiga line continued, but then, as we all know, that's history. And what did the Commodore 128 look like? Clearly, it was a machine that was backward compatible with the 64, and in my opinion, that was one of the main reasons it never really managed to make a name for itself, because those who bought the Commodore 128 would obviously end up using it as a Commodore 64. This is definitely one of the reasons that led to its downfall, so to speak, and also because very little software was actually written for this machine. However, the Commodore 128 had some truly unique features for its time. The main feature of this machine was that it was three computers in one, a 6 8502 with two banks of RAM, 64 plus 64 to reach 128, with a maximum expansion of 512, but it even had the possibility precisely to compete with the advanced machines that were starting to come out with MS-DOS. Do you remember CP/M, which was then replaced by MS-DOS? It had the Zilog because it was also possible to run, basically, the Commodore 128 in, as far as the Zilog was concerned. So when loading, it checks if the disk contains CP/M, and if so, if the operating system is present, it loads CP/M directly in 40 or 80 column mode, and so on. Clearly there were, and here you can see Commodore Basic 7.0 and CP/M, which was basically the ancestor of MS-DOS. This was probably what was included in the launch offer, and so on. I'll just add a bit more information. Obviously, enthusiasts already know this stuff. The development of the hardware server was initially problematic, but eventually, yes, they managed to solve these issues. Once these problems were solved, thanks to two graphics chips, it was able to offer various video modes. The 8563 could generate an image of up to 640-200 pixels at 80 columns through its RGBI output. And there were also, well, a series of monitors came out. For example, the 1901 or the 1084 from S2 come to mind, which basically had a small, what we now call RGB, what we now call VGA, what we call RGB. But it was a particular type of RGBI because it allowed you to connect the Commodore 64 clearly compatible with CGA signals, but it also allowed you to start up the 128 in what was the 80 column mode. We've basically already talked about the process of emission. I had already given a very quick overview of the features. We also saw that it supported 80 columns. The sound was provided by the MOS SID with 3 channels. Some even say that this MOS, well, this SID at least according to the experts, so to speak, had sound that was actually inferior to what the 6502 had. What can I say? It could have been, it could run at 1, 2, or 4 megahertz for CPM, and that's it. In native 128 mode, thanks to the MOS 8563, it could use 80 columns, and it uses BASIC 7.0, which we're looking at right now. In 64 mode, it was lowered to 1 megahertz, and the image was generated by the VIC-II, and even here, there were some difficulties in being able to use the VIC-II at the level of the Zilog. We also had this CPM mode, which we've talked about. By starting CPM, thanks to the result, the computer could launch and run everything that was written for this operating system. Well, you can't really call it retrocompatible with MS-DOS because in reality it was created earlier. In this mode, the computer could operate at either 40 or 80 columns. The resident BASIC in the 128, called 7.0, included advanced functions and the ability to control part of the audio. The startup screen clearly shows the Microsoft copyright, as we saw at the beginning of the video, for the BASIC language. All right, we'll wrap up here. We'll meet again here on the channel to continue our overview of BASIC, as well as to go over some more technical information about the 128's hardware. If you enjoy these videos, leave a comment. These will be short videos, obviously 3 or 4 at most, about the Commodore 128 to showcase some of its features. And if you're interested, we could also cover more advanced modes of the Commodore 64, CPM, and other topics. Otherwise, let's say we'll keep this historical overview confined to these short videos, which many of you might enjoy. Well, what else can I say? Thank you for staying with me up to this point, and I wish you all the best going forward. Claudio, Project CD Chronicles.